Okay. Hello everyone. So today we will have to illustrate SAS, ASA, and SSS congruence postulate and the AAS or SAA congruence theorem. So we will go first to SAS. So the meaning of SAS is side, angle, side. So that is SAS congruence postulate. So its definition said, if the two sides and unincluded angle of one triangle are congruent to the two sides and the included angle of another triangle, then the two triangles are congruent. Okay, I have here two triangles. So we have these symbols or markings on the sides and angle. Okay, so observe the two triangles first before we will write the statement. So after that one, so you will have to write just three statements, then we can prove that the two triangles are congruent. So it is SAS. So you will write for SAS. So we will follow the pattern side, angle, side. So the angle here means the included angle between the two sides. So first, we'll go to the figure. So here, I draw one line on side LA. So that is our first side. Congruent to here, that is side CU. So again, you can write AL, then UC. Okay. Next, angle. So here, I draw the curved line to angle A. So angle A is congruent to angle U. So don't write angle L is congruent to angle C. Okay? So follow the symbol or markings. Okay? Next, we have the side. So the side here is AR is congruent to side UT. So we have already the side, angle, side. So note that the statement 1 and 3 can be interchanged. So AR congruent to UT could be in number 1 and LA congruent to CU could be in number 3. As long as it follows the pattern SAS. Okay? So the middle statement is the angles. Okay? So we will write the conclusion. So therefore, triangle LAR is congruent to triangle CUT by SAS congruence postulate. Okay, we have this second example. So we have these two triangles. So based on the figure, we can easily determine the congruence postulate, okay? Because we have this one, side, the include angle, then the side. So that is already side, angle, side. Okay, so SAS. So we will just name the pairs that are congruent. So we will go first to side. First side, we have side QS is congruent to side SU. Next, included angle. So we have, this time we will name the angles in 3 letters because the two triangles are combined. Okay, so we have angle QSR is congruent to QSR is congruent to SUT. Angle SUT. Next side is side RS is congruent to side TU. So we have already side, angle, side. So we can have triangle. So we can copy this one. QSR is congruent to triangle SUT by SAS congruence postulate. Okay, let's go to the second congruence postulate, that is angle side angle. So what is angle side angle congruence postulate? So if the two angles and the included side of one triangle are congruent to the corresponding two angles and unincluded side of another triangle, then the two triangles are congruent. So it is the opposite of SAS or SAS. So this time ASA. So two angles and the included side. So if I will draw here the two triangles, for example, we have two triangles that were combined. So L, U, and then O. So before naming the congruent pairs or congruent sides and congruent angles, we will separate this one, okay, so that we have clear illustration. So the first triangle will be like this. So LUN. Okay, so I forgot here. So that is one. Okay, so if you will ask, where's the side? Okay, so the side here, if you notice, we have this common side. Automatically, this is the included side. So therefore, that is congruent already, or they are congruent. So if we write here, because this is the common side. Okay, so the common side is LN here. So this is our included side again. So LN is congruent to LN. Okay, so if we will have to name the congruent parts, since it is ASA, so ASA. So first pair is angle. So angle here, I have first angle AL. So L should be our vertex. So ULN. So angle ULN is congruent to ULN. LN. Here, L is congruent to N. So we can say ONL. Angle ONL. Okay. So make sure that L is in the middle because that is our angle. Okay. And also N here. Next is the included side. So the common side of the two triangles. So that is side LN is congruent to side LN by reflexive property. Next, the angle again. The second angle. So here, angle N. So we can write angle LNU is congruent to NLO. So we have that one, ASA. So therefore, triangle, so you can copy either the number 1 or number 3. So I'll choose 1. So triangle ULN is congruent to triangle ONL by SA congruence postulate. Okay, that's the correct statement. So, or you can choose triangle LNU congruent to triangle NLO. So that's still correct. Okay, we have the third congruence postulate. So if the three sides of one triangle are congruent to the three sides of another triangle, then the triangles are congruent. So that is the SSS, or the side congruence postulate. Okay, so this is just easy. So I will just draw two triangles. This one, so triangle ABC, then DEF. Okay, so based on the figures, so we just have the markings on the sides, okay, because just side. So side. So the first pair is side BC is congruent to side DE. Next, side BA or AB is congruent to side EF. Next, side AC is congruent to side DF. Okay, so just that's the congruence statements. Okay, so SSS. Again, still correct if your second pair is on the number 1, as long as it follows the correct pairing. Okay, so don't write BC congruent to DF, because based on the figures, BC congruent to DE. Okay, so by SSS congruence postulate, we can say triangle ABC is congruent to FED by SSS congruence postulate. Okay, we have this fourth one. So it is not a congruence postulate, but a congruence theorem. So again, theorems are statements that are derived where postulates was used to make that theorem approved or correct. Okay, so again, it is not a postulate but a theorem. Okay, so we have the AAS, or the angle side, or the SAA, or side angle. So the side there is not the included side. Okay, so we will draw a figure here. Okay, so based on the definition, if two angles and the non-included side of one triangle are congruent to the corresponding two angles and non-included side of another triangle, then the triangles are congruent. So here on the figure, the two triangles were combined. So we will separate to have clear illustration. Okay, so the first triangle is DRU. If you notice, I don't have the markings on the congruent side. So based on the figure, this side here is the common side. So therefore, UR and UR are congruent. Okay, automatically. Then we have the two angles. So that is angle side. So angle side. Angle side. So if you ask if it is ASA, I should write here this one, DR congruent to RM. But it is not. ASA or angle, side, angle, but angle, angle, side, or side, angle, angle. Okay, so we have angle, angle, side. So again, you can write the side on the first statement. Okay, so here I write the angle, angle, side. So the first angle is D, congruent to M. Since they are combined, we will name the angles in 3 letters. Okay, so you can write angle UDR is congruent to UMR. Next, R, congruent to R. So here, so you can write angle DRU. So DRU congruent to MRU. Angle MRU. Next, side. So the common side. So side UR is congruent to side UR by reflexive property. So that is angle, angle, side. So we can say that triangle, I will choose number 2 statement. So triangle DRU is congruent to triangle MRU by angle, angle, side congruence theorem. Okay, now it's your turn. So I just identify if it is SAS, ASA, SSS, or AAS. So please comment below your answers. Thank you for watching.